and Mrs. Reed was in for me yesterday. Went over the find the scale factor question, find the missing side questions, and here are some word problems using similar triangles. Solve those kinds of questions. Does anyone have any comments, questions, or concerns from any of the work that was assigned yesterday? Going once. Does anyone want me to do any of them? Twice. Before I say thrice and sold, I'm just looking at my notes here. Sounds like Mrs. Reed was really helpful to a lot of you. And it sounds like the people she mentioned in here by name that didn't do perhaps as much as they could have. Hannibal Lecter? Yeah. Yet another cannibal. Serial killer. Yet another obscure movie reference. Okay, so everyone's cool with these questions. Nobody wants me to go over any of them. Everyone's like, yeah, totally, rock this. So on a test or a quiz on Monday, perhaps, you'll be fine? Yo, yo. Nope. People are looking, I don't know, they use my extension looking for, this is Steven, looking for Kathleen all the time, and it's never her. I've corrected who gave you this number? Oh, I see. I told Allison back in September to change that, so I'm sorry. I don't know what it's supposed to be. Okay, bye. Okay, here we go. So nobody. Number 12. There we go. Here we go. A model igloo is 8 inches wide. If it was built with a scale of 2 inches to 3 feet, then how wide is the real igloo? Okay, so recall, scale factor is diagram or model over original. So what they're giving you here, there's 2 different scale factors. They say, no, not different scale factors. There's 2 equivalent scale factors. What they're telling you is that the scale factor is 2 inches per 3 feet, and they tell you that in the model is 8 inches wide. How long, or how big rather, in feet, wide, is the model igloo? So this is how you're setting it up. If it's written like this, the first thing listed is the numerator and the fraction. The second thing is the denominator and the fraction. This is diagram over original. So the model is 8 inches. How big is the real? And now we want to solve this thing. I gave you 2 techniques for this. Either you can isolate for x by multiplying and then dividing, or the first step could be take the reciprocal of both sides. I think that's easier, so that's the way I'm going to do it. So this is going to become 3 feet over 2 inches equals x over 8 inches. And now to get x by itself, it's just one multiplication. I'm going to multiply the 8 inches. The 8 inches is going to cancel on the right. The inches is going to cancel on the left. And I'm going to get 8 times 3, which is 24, divided by 2, which is 12. And the feet are still there. Does that make sense? Carson, you just changed your answer. I was asking Hassan jokes, but then you're shaking your head vigorous. Are you cool with what just happened here, Carson? Okay. If you're not, you can say that. But now I've drawn so much attention to you at this point that you're just embarrassed. Want me to stop talking to you? Yeah, maybe. No answer is an answer. Yes, Sarah. Let's do number 13. Find the distance between Madison and Union. Those are streets on a map with a scale of 1.2 inches to 7.6 miles if they are actually 12 miles apart. So this is going to become the scale fraction. I'll write this as 1.2 inches over 7.6 miles. This is the diagram, and we're asked to find the distance on the map. So that's what we're looking for. The distance on a map is the numerator over 12 miles. So now to get x by itself, I just need to multiply both sides by 12 miles. Here that's going to cancel. Here the miles will cancel. And we're going to get 12 times 1.2 divided by 7.6. 12 times 1.2, I think, is 14.4. Divided by 7. Is that correct? Divided by 7.6 should be 1.9. Zara, does that make sense? Okay. Last lesson. Here we go. Flip the page. Find me this. Unit conversions. Okay, this lesson we're going to look at unit conversions. Converting back and forth between various metric units and then back and forth between metric and imperial. So, converting metric units. In Canada, we sort of use the metric system. Canada's weird. If I were to ask you for various measurements, you wouldn't always use metric, even though nationally that is the standard. If I asked you for your height, you'd give it to me in what units? Feet and inches. If I asked you for your weight, you'd tell me probably in pounds. Does anyone know their weight in kilograms that doesn't have a driver's license? Okay. Some of you. Other parts of the world, it wouldn't be a big deal. You'd be like, yeah, there's my kilogram. Yes, Matthias? Okay. I only know because I would convert. So like Canada has this kind of awkward middle ground. Other countries, fully dedicated. There's this other weird thing we do in Canada where if I asked you how far away something is, you probably would tell me, how would you describe how far away something is? Would you? If I asked you how far Vancouver was from here, what would you say? How would you answer that question? How far away is Vancouver? What was that, Bilal? Would you? No, that's an actual answer. How would you tell me how far away Vancouver is? Hours. Does that even begin to? Does that actually answer my question? Well, in Canadianese, yeah, of course that makes sense. How far away is Vancouver? Oh, it's about an hour. We are, and in all the traveling I've done, and I've done a lot of traveling, we are kind of unique in that regard. Someone asks you how far away something is. I mean, Vancouver is about 70 kilometers away. Like if you, in the actual answer to that question, about 70K. But when we ask that question here in Canada, what we're really asking is how long will it take me to get there? And we do this all the time. How far away is Calgary? About 10 hours. Does it answer the question? Not the question that was asked, but the question that was implied. Perhaps, yeah, that's... So you gotta be, yeah, we're weird that way. And apparently this is a uniquely Canadian phenomenon. I digress. The metric system is wildly important. Only 2 countries don't use this. And even in one of those 2 countries, because one of those 2 countries has a really robust scientific endeavor, set of scientific endeavors, anything sciencey in that country would use the International System of Units. We call them the SI units, which I know is backwards. It's the International System, so SI is backwards. But this abbreviation comes from the French, and French speaks it all backwards. The Système d'International, so, which is obviously French, is all based on the metric system. So let's look at how we convert the metric system. The metric system is all based around what are called base units. In math, it's different than in physics and in chemistry, but in math, the base unit for mass is what? Someone say it louder. What is the base unit for mass in metric system? Almost. It's not kilograms. Because kilo is a prefix. You could have a milligram. You could have a centigram. You could have a kilogram. Those are all multiples of a base unit. What's the base unit? It's there in the word. It's the gram. The gram is the base unit. And everything in, or all of the other masses are based on multiples of 10 of the gram. Gram, we use the lowercase letter g. The base unit for length is what? The name of something with no prefix. The meter. And meter is spelled M-E-T-R-E, not E-R. Meter with an E-R is like a parking meter. Meter with an R-E is the, I'm going to use this to measure something, meter. And we use the lowercase letter m for the meter. If I wanted to measure capacity or volume, how much something holds, what's the base unit for that? It's not a gram. It is not a meter. It's the liter. Also spelled with an R-E. L-I-T-R-E. The litre. Been asking that question all semester. Denoted by the lowercase letter L. So then prefixes, originally Greek and Latin words, are written in front of those base units to give us multiples of that base unit. Go pick that up. And do not throw things in my classroom, sir. I keep finding garbage places, and when I catch it, I'm angry when I find the garbage. When I find out where it's coming from, I'm even more upset. Go throw that in the recycling. So these prefixes are used as multipliers. For example, kilo means 1,000. So the classic example is the kilometer. If I have a kilometer, that means I have 1,000 meters. There are some that we don't use very often. Hecto and deca we don't use very often, but hecto means 100 of something. If you have a hectometer, you have 100 meters. If you have a decameter, you have 10 meters. The base unit is just one of whatever it is. Deci is 1/10. Centi is 1/100th. So if you have a centimeter, you have 1/100th of a meter. And milli, 0.001, that is the thousandths place, all the way back from the first day of September. So if you have a millimeter, you have 1/1000th of a meter. So these prefixes, and this is the beauty of the metric system. The beauty of the metric system is that all we're doing is multiplying and dividing by groups of 10. Why is this a really nice way to operate mathematically? What are you doing, Abdal and Bilal? That's what I thought. Not related to what we're supposed to be doing. What does multiplying and dividing by 10 do? The only thing it does is what? Well, there's two things. Not necessarily. Multiplying a number by 10 does what to it? Does what to a number? Adds a 0 to the end. Multiplying a number by, like, 6 times 10 is 60, 60 times 10 is 600, 600 times 10 is 6,000. Multiplying by 10 just tacks on zeros. What does dividing by 10 do? Takes off zeros, and if you run out of zeros to take off, it just starts shoveling a decimal around. This is the beauty in the metric system. It's all just jumping decimals. There's nothing, no ridiculous numbers to memorize. You're just moving decimals left and right. That's it. So converting in the metric system is nice and easy. Don't flip your page. I will flip my page. We're also going to look at converting between the imperial system. The imperial system is trash for reasons like this. 1 mile is 5,280 feet. 1 mile is 1.6 kilometers. An inch is 2.54 centimeters. There's all sorts in the imperial system. There's all sorts of ridiculous numbers to memorize that were based on, we'll talk about what they were based on in a second, but that weren't standardized the way the metric system is. So let's look at a really convenient way to move around in the metric system. Here we go. In the metric system, I will show you a complicated way to do some of these examples, and then I'll show you a nice, really easy way to do it. So the complicated way is something we're going to have to use later for something else, but it's the factor label method. And let me show you how the factor label method works. Using this first example, I'm going to take 20 liters and I want to convert that thing into milliliters using this slightly complicated mathematical operation. Lucas, do you have a writing utensil? Are we using the writing utensil? It's in the bag, so no, we're not. Okay. 20 liters. I want to take my 20 liters and I want to convert that into liters. Milliliters, sorry. Some of you will be able to do this really easy in your head. You will recognize that, yes, there's 1,000 milliliters in a liter, so I'm just going to multiply this by 1,000. We're going to call it a day and move on. But I want to expose you to this other method here. So 20 liters, what we're going to do is we're going to treat it like a scale factor. We're going to use a scale factor conversion, like we've been doing, to convert this thing from liters into milliliters. Now, the thing that we're trying to cancel goes on the bottom. I want to get rid of liters, and I want to put it into milliliters. So the thing I'm trying to get rid of, the liters that was on top, goes in the liters go on the bottom, and the new unit that I want goes up top. And we're going to go ahead and hop over to this conversion. 1 liter is equal to 1,000 milliliters. So I'm going to take these two numbers and I'm just going to put them into our fraction. 1 liter is equal to 1,000 milliliters. And now I'm just going to do the multiplication. I'm going to take my whole number and I'm going to multiply it by this fraction. Well, this whole number goes over 1, and then I multiply numerators and I multiply denominators. So 20 times 1,000 is 20,000. My liters cancel, and 1 times 1 is 1. I don't have to put, when it's 1, I don't have to put it on the bottom. So my liters have canceled, and I just multiplied by, there's 1,000 milliliters in a liter. Now, the method isn't that complicated, but you don't necessarily want to write it out every time. And I will be giving you this chart on a test or a quiz. So let's take a look at a shortcut. These are all of the jumps of 10 that we're going to look at. These are not all the jumps of 10 that exist, but these are the jumps of 10 that we're going to use. The base unit is the column in the middle. The deci, the centi, the milli are on the right. The deca, the hecto, the kilo are on the left of that middle column. Let's put this answer in here, 20,000. And if we take a look at what we did, then there's a shortcut that we can glean out of here that some of you might find useful. We started at 20 liters, and a liter is a base unit, so here we are in that middle column. We wanted to convert it over to milliliters. So how many columns away is the milliliter column? Yeah, 3. 1, 2, 3. 3 to the which way? To the right. So all that we did functionally is we took our number of liters, 20, we went to where the decimal place was, and we moved the decimal the same number of times that we moved columns in the same direction. Moving to a smaller unit to the right, we move 1, 2, 3 decimals to the right. We add zeros in those spaces, and we found that 20 liters was 20,000 milliliters. So if you've got the chart, all you have to recognize is, oh, whatever direction I am moving from where I'm starting is the direction I'm going to move my decimal, and as many columns as I go, that's how many times I jump. For example, let's do the next one. If I have 20 liters and I wanted to go into kiloliters, from the liter, which is this column here, which way am I going to go to get to kiloliters? I'm going to go 1, 2, 3 to the left. So in order to figure out what the kiloliters are, I'm going to start with my 20 and I'm going to go 1, 2, 3 to the left. So 0.02 kiloliters is 20 liters. I'm going to verify that this works. I'm going to show you the factor label method one more time. 20 liters, I'm going to multiply that by kiloliters over liters because I want to get rid of the liters. And we can use the conversion here. 1 liter is 0.001 kiloliters. So 1 liter goes on the bottom. 0.001 kiloliters goes up top. If I multiply these, the liters are going to cancel. I multiply 20 by 0.001, and we're going to get 0.02 kiloliters. Kiloliters. But if I give you the chart, you can avoid this and just go straight to some of these conversions. I'll do 2 more and then I'll leave you to play with some of these. Let's jump down to this one, the 250 centimeter one. And I'm going to use the chart like I've been showing you. If I have 250 centimeters, the centimeter column is this guy right here. If I want to convert my centimeter column into meters, to get from the centimeter column to the meter column, which way am I going? Centimeters to meters? I'm at centimeters, and I want to move to meters. I go left twice. So if I'm going to go left once, twice, I'm going to go to my number, and I'm going to go, the decimals at the end, I'm going to move it twice. So then 250 centimeters should be 2.5 meters. And again, I'll verify this using the factor label method. If we have 250 centimeters, and I want to convert that into meters, I'm going to put centimeters on the bottom and meters up top. 1 meter is 100 centimeters. So I multiply across the top, and then I do my division. So that's going to be 250 over 100. 250 over 100, that just is 2.5. So the column counting works. I'm at centimeters. I want to move to meters, so I'm going 2 to the left. So my decimals do as well, 2 to the left. I'll do 1 more, and then help where needed. If I'm at centimeters and I want to go to millimeters, what do? We okay? Okay. Lucas, do I have to move you? You sure? Okay. If I'm at centimeters and I want millimeters, which way do I have to go? How many columns? 1 to the right. So I'm going to take my number, I'm going to go where the decimal is, which is at the end there, and I'm going to move it 1 to the right. Wherever I create a space, I have to add a 0. So 250 centimeters is how many millimeters? 2,500. Sure, you may. Okay, fill in the chart. On your mark, set, go. Same method. See what you can do with it. Yes, sir.
Did you do the last 2 pages?
Not yet. Yeah, but I mean, don't do this page yet. The converting between metric and US, we will. Well, I mean, you can if you want, but that's going to be a lesson we're going to do here in a second. Okay. Okay. Okay, let's go, guys. Yeah, I'll take it. I'll throw it for it. Yes. No. What did you do? Why did you go to the left? You're in kilo. You're going to grams. Right. That's you went too far. Why did you go for 5? Why did you go for 5? One of the mistakes I saw in my earlier one class was that they would count this as 1. 1, 2, 3, 4. You're starting here, you're only going to 1 and 2. Don't count the column where you're starting as the 1. Truly, you mean 3 jumps, not 4. This one. Plastic bag wrap. Had enough of it. And then you would add zeros. So just 2. Get these empty spots. How's it going? Questions, comments, concerns? Lasagna. My daughter ate lasagna. Of course she did. Okay, I want to show you what the answers should be for this. Are we hands up if you're done the chart? Hands up if you think you could finish the chart given another 2 more minutes. Well, some of you are not paying attention because you're actively working. You know, okay, fine, I'll give you a couple more minutes. Finish the chart and I'll give you the answers. Make sure we're doing it properly. Okay. Okay, here's what you should get. Take a look. Comments, questions, concerns on any of those? Would anyone like, the pink ones are the ones that you should have not done with me as examples. Ones that you should have done on your own. Comments, questions on any of those? Is there anyone there? Anyone would like me to do? You feeling okay with this stuff? I like that attitude. Yeah, I get it. It's good. That's what I like to hear. I don't know. I felt it. Someone thought it, and I just sensed it. Okay, if there are no questions, if we are feeling okay with this stuff, then I am going to give you 15 minutes to complete this page, and then at 2 o'clock, I'm going to go do. I will finish the rest of the lesson. So this is your first page for homework. You have 15 minutes to get her done. This whole page. On the bottom, you're comparing using greater than, less than, or equal to symbols. And if you have any questions about those, please let me know. Otherwise, get to it. You have 15 minutes, and then I'm going to finish the lesson. If it helps, grade 9s, if it helps, the very back page in your book, this guy is the, okay, grade 9s, I want all you to look up here. The last page in your book that has the conversion charts on it, You can use it now, and you will get it for this chapter quiz test thing. Okay? So if it helps, you can tear it off. Boom. So that you're not constantly flipping pages. And while you're working on this one, you can have this one beside you on your market set giver. 2 o'clock, we will look at converting between metric and imperial. Unless you're Sean, in which case you're probably done. Yes?
What's the block?
Bad to see. Number skills. Polynomials, algebra, I am giving these guys a tweaking a test. But I am ready. Oh, fine. Amazing when you can do both. Amazing when you can do both. You didn't need that. I don't know why you're using it. You're just moving that space. Yeah, you have more than your little lies and sports. Okay, 2 o'clock, we move on.
Let's go. I didn't want to be him. I said I want to be his friend. That's worse. If I could tell by okay. What? Okay, alright. Okay, like, look. Oh, wait, it's or no, or is it equal to that? So, here's one. So, $30 on this card. She's $8. That's $30. Look at how hard it is, bro.
I know, right? Like, I'm surprised right now. I didn't know. Michael Jackson. Michael Jordan. No, no. This guy, bro. You even know me. Yeah. Okay, look at this guy.
Okay, I will give you the answers to that tomorrow. Flip the page. Flip the page. We're going to do one more thing today. Flip the page. Here we go. I will give you answers to that tomorrow. So, the metric and the American system. Here we go. The U.S. system of units has a name. Ironically enough, it is called the imperial system. It is used by two countries, the United States, and does anyone know the other country? That still leaves like 185 odd countries it could be. It's Myanmar is the other country that uses this system, which is interesting that they still use this system. Does anyone know where the imperial system originated? No. Good guess, though. Very close geographically. When we call something the imperial system, that's referring to the fact that it comes out of an empire. And on this planet, when we talk about the empire, it's not Rome, it's the other one, the British Empire. So any country that was originally colonized by the UK, by Britain, would have had this system of measurement introduced to it. And it's not the entire world, but it is an awful lot of it. And interestingly enough, even after the Revolutionary War, when the United States was like, nah, get out of here, Britain, they kept the imperial system, even though Britain and the rest of the world moved away from it. So that's interesting. It comes from the original set of some of these. It came from some kind of ridiculous methodology. The foot and the inch was based on the most important thing in the empire. And the most important thing in the empire was what? What's the most important thing in the empire as far as the empire is concerned? Sorry, you said the emperor? You would be correct, except in Britain they don't have an emperor, they have a queen or a king. So when we looked at some of these units, back in the day it was only kings, they didn't have queens. Queens didn't show up till Victoria, I think, was the really like the first legit on her own queen. The foot and the inch were based off of that ruling monarch. The foot is named the foot because it was based off the length of the king's foot. But you change kings, and now all of a sudden, if the foot size isn't the same, your foot's not the same length anymore. The inch was the width of the king's thumb, which you change the king, now you change the width of an inch. And so eventually these were standardized. They said, okay, we can't keep doing this. You know, when you start having kings after kings change every couple of years, and near the end, they didn't have a lot of time, started fighting lots of wars, kings died, they intermarried, kings were sick, it was bad. They started moving through kings quickly, and so they had to start changing the feet and the inch relatively quickly. So they finally standardized it. The inch, I believe, was related to barley seeds, like a certain number of barley seeds stacked next to each other. Even that's a little bit ridiculous. And so France was responsible for this. We have the metric system. The French are fantastic for their neuroticism. And just like they've taken their language, and the French language is ruled by an academy that determines what is a valid French word and what is not a valid French word. The scientific community in France did the same thing with the metric system. That's why we have the metric system. It's one of the few things from France that I'm very grateful for. There's other things, but the metric system's a big one. And so let's look at how we convert between them. There is this conversion chart, and as you can see on the page I had you rip out, there is a chart there on the bottom for conversion between the metric system and the imperial system. It's a useful skill to have because last time I checked, the US was a fairly influential country in the world, and so being able to convert into and out of their units is useful. Also baking. There's baking units built all over the imperial system. Liters to milliliters, ounces, even cups, teaspoons, tablespoons, all of that is connected to the imperial system. So it's useful to be able to convert. And this is where the factor label method really shines. Factor label method. I'm going to demonstrate the factor label method on 3 of these examples, and I'm going to let you play with it. Here we go. Here's how it works. I'll show you again. This first example says, I want to convert 40 meters into feet. Now, this is not going to be as simple as moving decimals around, because if you take a look up here, there's all sorts of conversions here. This first stack, that's metric. We like those. Feet get interesting. 1 foot is 12 inches. 1 yard is 3 feet. 1 mile is 5,280 feet. And if you look over here, where did it go? 1 foot is 0.305 meters. So this guy right here is the scale factor that we're going to use, or the conversion factor that we're going to use to take our 40 meters and convert it into feet. And it works the same way a scale factor does. We're going to start with what we know. We know we've got 40 meters, but we don't want 40 meters. What we're going to do is we're going to use this thing as a scale factor to multiply to get rid of the meters and give us feet. Because we've got meters up top in our conversion factor, I'm going to put the thing that we're trying to get rid of, the meters, in the denominator. Because having it in the numerator and in the denominator means it's going to cancel. And I'm going to put what we want in the numerator. We want feet. And we have a nice conversion between feet and meters. It says right here that 1 foot, so I want to put that 1 foot, is equal to 0.305 meters. Lucas, I'd like you to get your calculator handy. We're going to multiply across the top, we're going to multiply across the bottom, and so what we're going to get here is 40, the meters are going to cancel, divided by 0.305 is going to be in feet. Lucas, what is 40 divided by 0.305? 1.305, and I'd like you to round it to 1 decimal place.
131.1.
Thank you. So 40 meters is 131.1 feet. And so we've used the factor label method to cancel out the units we don't want to give us the units we do. Let's take a look at the next one. I've got 21 inches and I want to put that into centimeters. So we're going to start with what we've been given. We're going to multiply it and we're going to see, do we have a conversion that'll take us back and forth between inches and centimeters? We do, it's right there. Scarlett found it. 1 inch is 2.54 centimeters. And so now we're going to put the thing we're trying to get rid of, the inch, goes in the bottom, and the thing we're trying to convert to, centimeters, goes up top. This is going to cancel our inches because it's up top and in the bottom. They divide away. And now we're going to put our values in here. Now, the 1 goes with the inch in the bottom, and the 2.54 goes with the centimeters up top. Now all we have to do is multiply across the top. What is, Lucas, 21 times 2.54? Or Jacob, if both of you have calculators up. Can you round to 1 decimal? 53 point what? Is it 53 point? I didn't hear the second thing you read. So 53.3. Okay. So 21 inches is 53.3 centimeters. Cool. Let's do one more. I've got 520 centimeters and I want to convert that thing into feet. Looking at the chart that I gave you, is there a nice conversion between centimeters and feet? No. A few of you are starting to find it. Carson, Bilal, and Hassan Jod all said no. All three of you gentlemen are correct. There is no nice conversion. But are there multiple conversions that we could use together to give us what we want? Hassan Jod says yes. Hassan Jod, what did you find? We want to go from centimeters into feet. So we've got a couple conversions that we can use. This method works with multiple steps. We can do this here too. Is that the only path we could follow? This one takes us from centimeters and then inches into feet. Is that the only option? Scarlett, did you just shake your head no? No. You would have been correct if you'd said no. It's not the only path we can take. Is there another path that would take us from centimeters to feet? Take a look at the chart. Messiah, did you find it? Hassan Jod, did you find it? Scarlett found it? Scarlett, what is it? Yes. You can go from centimeters to meters and then meters into feet. So I will show you both and I will show you that they give you the same thing. Here we go. I'm going to throw a vertical line here down. So there's two paths we can take. When there's not one nice clean jump, we can do two different ones. The first one that you guys said was centimeters into inches and then inches into feet. So that's the one I will do first. We're starting with 520 centimeters. We're going to multiply it by something. Now we can't go straight to feet. So we're going to convert it into inches. So I'm going to put my centimeters on the bottom and it's going to give me inches. Right away, I'm going to write down the second conversion factor, something that will get rid of the inches and put it into feet. So you can see here, the centimeters on top, centimeters on bottom are going to cancel. And then the inches it turned into are going to cancel with these inches on the bottom. And at the end of the day, we're going to be left with feet, which is what we want. So then let's take a look at those conversion factors. You guys found, I think it was Haas and Jote said it, that 1 inch equals 2.54 centimeters and 1 foot equals 12 inches. So I'm just putting the numbers from our conversion factors into these fractions. We're going to multiply across the top, we're going to multiply across the bottom, and we're going to get a fraction that we can then divide. 520 times 1 times 1 is 520. And then 2.54 times 12 is 30.48. If I do that division and I round it to 1 decimal place, what is 520 divided by 30.48? Rounded to 1 decimal place. Okay. Okie dokie. Let's check the next one. The next one you guys said was centimeters into meters and meters into feet. Let's take a look. Hold on. 520. We're going to multiply that. We're going to put the centimeters on the bottom, the meters on the top, and then we're going to multiply that by meters on the bottom and feet up top. This will cancel our centimeters, cancel our meters, and give us feet. So 1 meters is 100 centimeters, and 1 foot is 0.305 meters, based on the conversions up at the chart on top. Again, we're going to multiply across the top and multiply across the bottom. That's going to give us 520 divided by 30.5. 520 times 1 times 1 is 520. 100 times 0.305 is 30.5. If I do that division and I round it to one decimal place, what do I get? 17.0. Doesn't matter which path you take. If you round it appropriately, you end up where you want to end up. And that's it. We are done. So, sorry. This is your homework. This page right here. You have 10 minutes till the bell. Please use that time. Do not just pack up. We'll go over all the answers tomorrow. On your mark, get set, giver. And I'm done. So.
This one?
Yeah.
I saw it was 17.0.
Oh, so it should have been 17.1? Okay. Usually I round it to 1 or 2 decimal places. But 17.1 and 17, very close. You're right, that should have been rounded differently.
Oh, no, I just thought, like,
No, you're good. You're right to bring it up.
because I figured you already done this in the other classes. I didn't know if I would have been right or not.
I got the same thing told to me twice, which means 2 people made that same rounding mistake.
What was the reason?
Yes, sir. You bet. Okay. Where is my this pencil? Bilal, are you done? You done? Can't answer it in 8 minutes when class is over? Okay. Do what you gotta do, Bilal.